Hi everyone, I am Dr.Sruthi. I am working as an assistant professor in Department of Biostatistics in SDM Vaishnav College. Okay. Today let us see about applied regression analysis. So before entering into the topic, let us see what is regression analysis. Nowadays we come across a term called regression in machine learning as well as in data science. Am I right? It is most commonly used for prediction and one of the most sought out analysis. So what do you mean by regression analysis? It is nothing but a set of statistical procedure that is used in what is regression analysis? Regression analysis is nothing but a set of statistical procedure that is used in statistical modeling to determine the relationship between one or more independent variables, okay, when to a dependent variable. So independent variables is often referred to as predictors, covariates, okay, and independent variable is otherwise known as label. Now let us see about the history of regression analysis before entering into our simple linear regression. So the word regression was first used by Sir Francis Galton in the 19th century to refer to a biological purpose. This is nothing but he used the term regression to compare the heights of the descendants of tall ancestors, okay, that tend to regress towards a normal average person. So he only used it for biological meaning, okay, but this purpose was changed when Eugene Yule and Carl Pearson worked on this model and expanded it to a wider statistical context. So before entering into regression model, let us see about a base of the regression analysis. So the base of the regression model is taken from a linear model which is nothing but y equal to a plus bx, otherwise known as y equal to beta naught plus beta 1 x1. Here as you can see, y is nothing but your y-intercept which is otherwise known as dependent or response variable, whereas beta naught and beta 1 are slopes which is nothing but independent variable or the otherwise known as response variable, whereas epsilon is a random error. So this is the basic for the regression model, okay. So this linear function is nothing but it gives the relationship between an independent and dependent variables. Now let us move on to the types of regression model. There are two basic types of regression model. One is a simple linear regression, another one is a multiple linear regression. So in simple linear regression, we use only one independent variable to explain or to predict, whereas the outcome or the dependent variable is termed as y. Whereas in multiple linear regression, we use more than two independent variables to predict the outcome. Okay. Now let us pass on to the uses of the regression analysis. So the main uses of regression analysis are forecasting, prediction and time series. Now let us pass on to the method of least square. So from now on we are going to use how to analyze the simple linear regression model, okay, and what are the terms that are used to measure the model. First one is the best fitting straight line to the data. In method of least square, we used to get the straight line, okay. This straight line has been given in the form of red, whereas the green dots represents the variables, your independent variables, okay. Here the best fitting straight line to the data is given as an example here for a salary and years of experience, whereas the other point is determine which straight line has a smaller feasible gap between the actual value of y and the values that the fitted line of regression, which is otherwise known as y hat, would forecast or predict. Measures of variation. These are some of the important terms that are used in regression analysis. First is the regression sum of squares, otherwise known as the explained variance. Another one is the sum of squares of error, which is otherwise known as unexplained variance, and total sum of squares. These three terms are used to measure the variation of simple linear regression. Now let's pass on to how to check the quality of the model. So the quality of a regression model is usually determined by R square value. Okay. So this R square value usually tells us what percentage of the differences is explained by the model. Okay. So when an R square is of 0.68, which means that 68% of the variance in the observed values of the dependent variable is explained by the model, and 32% of those differences remains unexplained in the error term. So whatever the software you use, the R square will be always determined by point some values. Okay. So that's why the values are given here. So now let's pass on to the simple example. So the formula to estimate weight based on the height information. So this is an example I have taken here. So in this case, a person who stood 70 inches tall would be expected to weight. Okay. So the expected, so the person who is of height 70 inches, let's determine the weight of that person. So we are investigating the effect of one independent variable on the result in this straightforward linear regression. Should height be the sole factor influencing body weight, or shall we anticipate that each subject's points would be situated in close proximity to the line? Since we are only accounting for height, we might anticipate that the points for individual subjects would be more loosely distributed around the line if there were other factors or independent variables that affected the body weight in addition to height, such as age, calorie intake, exercise level, resting level, food, etc. We might expect that the points for individual subjects would be more loosely scattered around the line, since we are only taking height into account. You can also see this example in the form of a graph where your x-axis is your height and your y-axis is your body weight, which is measured in pounds, whereas height is measured in inches, and weight is equal to 80 plus 2 into your 70, which gives you the weight of 220 lbs. Okay. So this is a simple example of how to calculate our simple linear regression by using hand calculation. So can you always use the software such as R, Python or SPSS to calculate the simple linear regression model. Thank you.